Hello dear friends, welcome back for another exciting video. This is the second part of the series Atmospheric Crude Distillation. In first part, we learn how to create petroleum assay from different crude oils, and in this part, our main objective is to set up the crude distillation unit with the three side strippers and three pump arounds in HYSYS, and similarly we will simulate the atmospheric distillation column. Okay, so as I mentioned earlier, our final objective after four videos would be to have these four different units crude oil preheat train that we already have simulated in previous video. The link of previous video is in the description, just go and check it out. And for today's video we are going to simulate atmospheric crude distillation, and then in next video we will do debutanizer simulation, and finally in part 4 we will perform vacuum distillation. Okay, so here are the parameters or the data which is required to simulate distillation column. So first thing we have to notice that how many number of trays there. So the total number of trays are 50, and the numbering is starting from top to bottom. And here different tray numbers have different efficiencies. Okay, so the condenser type is total condenser, and the distillate product rate is given. Reboiler, this column don't have any reboiler, direct fire heater. So the pressure is given for condenser, top tray and bottom tray. Temperature of top and bottom trays are given, and the feed location is also given, that is 40. And at bottom the stripping stream is being introduced at tray number 50. The flow rate, temperature, pressure are given, and the feed heater outlet temperature is also given. Okay, so let's start the simulation of this distillation column in HYSYS. So now we are in HYSYS. So this is the process flow diagram that we have constructed in previous lecture. So if you want, you can just go to the previous lecture to see how we have created this one. Okay, so let's move to the to simulate the atmospheric crude distillation unit. So for that, just click on models and stream palette, and from here go to the separators, and from separator click the reflux absorber, because this distillation column do not have a reboiler, so that's why we are selecting this particular one. So double click on it. So the condenser is total condenser. We have a water, overhead water. So we are saying that it's ATM water, and overhead liquid is naphtha. So the condenser duty is QC. Okay, the number of stages for this distillation tower is 50. Okay, and the inlet feed is hot crude, and the feed stage is 40. At bottom we are introducing ATM steam, and from bottom we are receiving ATM atmospheric residue. Okay, so after that the stage numbering should be from top. Okay, click next. Here we have a condenser pressure. So the condenser pressure is given. Condenser pressure, so the condenser is 4 psig and top tray is 12, so the pressure drop will be 12 minus 4 8. Okay, so the 4 8 and 22. So this one is 4, but it is in PSIG. This one is 8. This one is 22. Okay, so 4 8 22. Just confirm 4 8 22. Okay, so then click next. Here we have a condenser temperature. So the condenser temperature is given. The total condenser temperature is 130. Okay, so just 130. Top stage temperature and the bottom stage temperature, it's also given here. So the tray 1 250 and the bottom tray is 650, 250 and 650. So this one is 250 and this one is 650. Okay, and then click on next. Liquid rate, it is in volume. So the top one is naphtha. So for naphtha we have a distillate product. Approximate flow rate is 30,200 barrel per day. 30,200 barrel per day. Okay, and then click done. Then this new window will pop up. From here, go to the side options and click on side option input expert. So this new window will appear. So it says reboiler side stripper. We do not have reboiler type side strippers. We have steam stripper side stripper connection. Okay, so just add. So the first one is kerosene stripper and the steam name is kerosene steam and the product is kerosene. Okay, so for this total number of trays are 10. Okay, so you can confirm here. Side stripper kerosene stripper, total number of trays are 10 and the draw from 10, return at 6. Okay, draw from return at 6, draw from 10. Okay, and then just install. Okay, the second stripper is diesel stripper. So it is 16 and 20. Okay, so this one is diesel stripper, diesel steam, and the product is diesel. So return is at 16, draw from 20, and total number of trays are 10. Okay, so 16 20, just confirm 16 20. Okay, then install. The last stripper is AGO stripper and the steam is AGO steam and the product is AGO atmospheric gas oil. The number of trays for this one is also 10 and the draw return stage is 26 and draw stage is 30. Just confirm 26 and 30, that is okay. Install it and then click next. Here we have side rectifier connection that we don't have. Click next. Here we have pump around connection. Yes, just insert one. So the first one is Caro pump around, and it is drawn from 10, return at 7, 10 and 7. So stage number 7 and 10, install, add a new one, the second one, diesel pump around, and this one is 1720, 17 and 20, install. The new one is AGO pump around, and for that 27 and 30, 27 and 30, install and click next. So it says vapor bypass connection we don't have. Now we have to specify the draw stream flow rates. For example, how much is kerosene is passing. So for that, come here. So here the kerosene product, that is 8,800 barrel per day, 8,800, 8,800. And for diesel stripper, for diesel flow rate is 10,240, 10,240. And the last one is atmospheric gas oil, that one is 3,835, so 3835, 3835, and then click next. And here now we have to give the specification for pump around. So the Caro pump around flow rate is 25,000. Okay, so it is 25,000. Okay, next one 15 and 10,000. 15,000. This one is 10,000. And the second spec is given return temperature, not the duty. So for Caro, the return temperature 200, then 250, then 350. So it is 200, then 250, then 350, then press enter, click next, leave it as default, and we specify the side streams and pump arounds. Okay, now we have to specify the tray efficiencies. For that, go to parameters and then go to efficiencies, and here we have this table. So the efficiency type should be overall and the efficiency value should be user defined. Okay, so from tray 1 to 6, 80%. Okay, tray 1 to 6, 80%. How we can do that? Just write 0.8 here, and 1 to 6 just select and specify. So it is already changed 100 to 80%. And then 7 to 10, 50%. So change it 0.5, 7 to 10, then specify 7 to 10, 50%. Then 11 to 16, 70%. 11 to 16, 70%. So just specify 11 to 16, 70%. Then 17 to 30, 50%. So change it 50, 17 to 30, 50%. Then 31 to 39, 30%. 31 to 39, 30%. Then 41 to 50, 30%. 40 is the 100%. And for all the strippers, the efficiency is given 30%. You can see tray efficiency 30%, 30%, and 30%. Okay, so let's specify all of them. 30%. So we specify the tray efficiencies according to problem statement. After that, go to the worksheet, and now we have to specify the stripper streams and atmospheric towers steam values. So for ATM steam, we have this one. So the stripping steam, that is the flow rate is given 20,000, and temperature and pressure 500 and 150 psig. So let's first specify temperature and then psig pressure, and then mass flow rate, that is given 20,000 pound per hour. Okay, now the Caro diesel and AGO steam we will check. So for all the temperature, pressure, for all the steam values are the same, and also the flow rate, that is 2500 pound per hour. Okay, so here it is 2500, 2500, 2500, and the temperature pressure is also same, that is 500, and then 164.7. Similarly here 500 and 164.7. Similarly here 500, 164.7. So when you define temperature, pressure, and flow rates here, then go to the compositions, and we have to define the composition for these stream pure water. Just click one and normalize and click OK. Similarly for Caro stream, repeat the process, normalize, click OK. Same for diesel steam and AGO steam, click one, normalize, then click OK. Similarly for AGO steam, click one, normalize, and click OK. So now we have defined all the available input data. Okay, So just go to the design and go to the spec summary, and first go to the monitor and check the degree of freedom. You can see it's already 0. Okay, so it's time to run the simulation. Just click on run. So you can see uh, it is solving, and now it is converged. So this is the way how you can uh, simulate atmospheric crude distillation unit. So from the performance tab, you can see the results. Okay, the compositions, the flow rates, and the plots, column profiles. So you have all the data here. For example, flow rates, and you can have a flow rate graph. Sorry. Okay, so just close this one. So this is our final simulation of atmospheric crude distillation unit. So in next video, we will further treat naphtha in a debutanizer column to stabilize it. And in the next video, after that, we will do the simulation of atmospheric residue in vacuum distillation column. So I hope you understand it and like the tutorial. Please don't forget to like, subscribe the channel. Until next video, bye bye, take care.